Hello. In this lesson, we're going to continue on the homework guide. Okay, so last time we did the first one, right? We did the first one. So let's look at a case that in quadrant 2. Okay, sine x is in quadrant 2, x terminates in quadrant 2. So we have sine x equals to 12 over 13. 12 over 13. So let's see how we will find all the double angles, half angles. Okay, so let's get started. So this time we have sine x is given, but it's 12 over 13. And x terminates in quadrant 2. And we still want to find all of these quantities. Okay, as we analyzed earlier, we just need to find cosine. We just need to find cosine. Then we can just plug in. But here, there's some sine analysis. Okay, there's some analysis about sine. Okay, so these formula, we have them all right. But in order to use these formula, we only know sine. We need to find cosine. But in this case, unlike in the previous case, we have terminal in the second quadrant, right? So we're gonna mobilize our ARD, right? Everything, we have a formality, we have certain format. We know what to do. Hold on, how did I get that? Even though, wait a second. Huh. This is a picture I drew before. Never mind. That was pretty good pictures, wasn't it? But anyway, so why did it show up there and then disappeared? Interesting. Okay, I don't know. I don't know why. But anyway, in this case, we're going to draw just a rectangular system. We're just going to draw the rectangular system, okay? The very basic from the definition, nothing more, right? Because we don't need more, we just need ARD, right? So you just have to draw a picture. We just have to draw a picture to analyze the situation. In this particular case, we just need to find cosine. Okay? And from the information given, right, we know the terminal terminates in the second quadrant, okay? In the second quadrant. So suppose we draw the angle, of course, from the standard position, terminate in the second quadrant, right? And sine equals to 12. Sine of that angle is 12 over 13. 12 is y, right? 13 is the hypotenuse. 12 is 13. Hold on, let me make sure you see these numbers. Okay, make sure you see that. Okay, so I'm going to bring that forward so you can see it. Okay, we know that the angle terminates in the second quadrant. So the angle will terminate in the second quadrant, and the ratio is, sine ratio is y over r. So we know y, we know r. Y is 12, r is 13, right? R is 13. So you just measure 12, right? The height is 12, y is 12. So here's 10 and this somewhere, right? So 12, so we have 12, we have 13, 12. So something like that. That's probably is the terminal. Something like that, okay? So from that piece of information, we terminate in the second quadrant, right? And then we will draw a triangle, right? And the 12 is going to be the y, right? So this is 12. And we need the x. Why? Because that's a cosine. We need a cosine, right? So this is to be found. And what is 13? Where's 13? 13 is going to be here. Oh, wrong color, right? Red is for something else, right? So let me just use purple. So this is 13. Right, you can see by definition, now we have almost everything. We pretty soon, we get cosine x equals what? Cosine x is what? Cosine x equals to, if this is 13 and this is 12, what will be the red? Pythagorean theorem. Pythagorean theorem, right? 13 squared minus 12 squared, that's going to be 25. 25 taken square root, it's going to be 5. But x is on the other, this red is on the left, on the negative side, right? So this is going to be equals to negative 5 over 13. Okay, 5 over 13. So I'm going to show you the work about it. I'm going to show you the work about it. Okay, so let me see how I would do that. Okay, let's do this. Okay, I'm going to show you the work because this piece of work is important. Okay, so I'm going to redraw the picture. I'm going to redraw the picture. Okay, so the hypotenuse is going to be, okay, so there's a line there, right? That's a terminal. And there's a red. The red piece, right? And there's the blue piece. This is to be 12. And that's the blue piece. And make it thick. Okay, so that's our situation. So our angle terminates on this terminal. And the hypotenuse is 13. And y is 12. You see, we don't really need the unit circle, do we? We just from the basic definition of ARD. Okay, so now we assume the red. Okay, so let's mark a couple numbers. Let's mark a couple numbers. So I'm going to have to mark it from this software so you can see, so it doesn't disappear when I stop the zoom, right? So that the X piece, right, which is the red, it's going to be, see, this is going to be here. Okay, the red piece. The red piece X. Right, so that piece is X. And the blue piece we already know. Right, the blue piece we already know, that's 12, right? And 12, we're gonna put it, say, and let's make it 8. And that's the blue piece. That's the blue piece. That's 12. And R is 13. R is 13, right? So 13 is a hypotenuse. So we're gonna put it somewhere. Let's make it 7. Okay. And it doesn't matter what color. So I just keep it the black color. Oh, wrong place, 13. We need to move it over a little bit, right? 13, you need to move over, oh, negative 2.5, my bad, 2.5. There we go, this will do it. Okay, so 13. So the way to find it, to find x, basically we use the Pythagorean theorem, right? So we set up the Pythagorean theorem, right? So x squared plus 12 squared equals to 13 squared. Okay, so subtracting 12 squared on both sides, and we get 25, right? 13 squared minus 12 squared, wait, wrong. And that's equal to 169 minus 144. So that's equal, that will make x squared equals to 25. Okay, watch the following step. We take square root on both sides. Square root of 25, of course, equals to 5. But square root of x squared equals what? That's right, equals to absolute value of x. Absolute value of x is 5. Okay. But because x is in the second quadrant, okay, because the terminal is in the second, is in quadrant 2. Therefore, x is negative. If x is negative, the absolute value of a negative number is its opposite. So that equals to 5. So as a result, x equals to -5. Okay, so this piece of work is very important that you understand and know how to do it yourself. Okay, other than that, it's all pretty basic, right? So from sine equals to 12 over 13, x terminating in the second quadrant, we have discovered that cosine x equals to -5 over 13. So this is the entire process. Okay, this is the entire process. So let me show you how to write this piece of work. Here. If we talk about how to show work, right? If we talk about how to show work. Okay, this is how you show work. From here, you draw the picture, and you mark properly on your picture. And that 12 seemed to be rather awkward, right? So let me just move it over a little bit. Right? 12. So with that marking, we have x equals -5. And as a result, cosine x equals to -5 over 13. And then the rest is just substitution, okay? So let's finish it up, because we're going to discuss the half angle piece, how we're going to choose the sine, okay? So for the double angle, we have 2 times sine is equals to 12 over 13. And cosine is -5 over 13. Am I right? Yeah. Equals to, right, numerator times numerator, but here we get a negative number. So 169 under, right? 2 times, well, 5 times 12, that's 60. 60 times 2 is 120. Okay, 5 times 12, 60, yeah, that's negative. For cosine 2x, you can actually use any one of the 3 formula. right? Since we know sine x first, so we just use this formula, right? So 1 minus 2 times the square, right? The square, which is 12 over 13, and then square that. Okay, and that equals to, looking ahead, we have to find common denominator, right? So this is going to be 169 over 169 minus, this is going to be 169, right? 13 squared is 169. 12 squared is 144. 2 times 144 is 288. And we subtract these two fractions, and we end up with a negative number. Okay, so 169 will be the denominator. The numerator is 169. Subtract from 288. So 288 subtract by 169. What does that equal to? I'm being lazy. Okay, 119. 119 there. Right, so cosine double angle is found, and then tangent double angle, right? Tangent double angle would be, you can see none of these has any special values, right? So sine of 2x, plug in, cosine of that is plugged in. So here we have two negative numbers. Watch out, okay? We have two negative numbers. Let's see if the negative sign shows. This software is really weird. Anyway, it's good in a way. And in the end, negative divided by negative is positive. 169 reduced. So we have 120 divided by 119, positive. Half angle, okay? We have to determine the quadrant x over 2 is in, right? So now, since x is in the second quadrant, which means that x is between what? Second quadrant, between pi over 2 and pi, right? Between pi over 2 and pi. That's the second quadrant. If x is in the second quadrant, if we divide every side by 2, right? We divide this guy by 2. We divide this guy by 2, we get 4, and divide this guy by 2. Well, half x is in the first quadrant, right? Then, if half x in the first quadrant, then these will be positive. Okay, so that selection. So how to get from this inequality to the next inequality, that's how we, determine which, the quadrant, right? The quadrants. With that said and done, it's just the rest is the plug-in numbers. Of course, this time the number is a little bit more complicated, but I'm sure you guys can do it, right? It's all it takes is just patience and practice. Cosine x here is negative 5 over 13. Okay, so cosine x will be substituted by negative 5 over 13. If you like to pause the video, pause the recording and do it on your own, that'll be great. That'll be great, okay? I encourage you to do that eventually all by yourself, So let's continue. 1 minus negative 5 over 13, that will be 1 plus, right? That'll be 1 plus. So we have 1 plus 5 over 13 and make common denominator 13 under 13. So in the end, on the top, we have a 13 common denominator, 13 plus 5, that makes 18. Right? It's sort of basic math, All it takes is patience. All it takes is patience. So we got this, and so here you're going to multiply 13 on the top and multiply the 13 on the bottom. And then what do we get? There. The top 13 and 13 reduce, so we have 18 left. The bottom is 26. We actually can reduce 18 over 26, right? Because the common factor is 2. So let's do that. So this piece, if we divide 18 by 2, 26 by 2, and this will be 9, and this is 13, right? And square root of 9 is 3. This is pretty long, right? But we can do it. Okay, so we have on the top is 3, the bottom is root 13. Rationalize it, right? We multiply root 13 over root 13, right? So in the end, we get 3 over 13 multiply root 13. It's not terribly difficult, right? It takes patience though. It does take patience. And next, work on this one. Okay, so once again, if you want to pause and do your own, feel free to do that. So here we have 1 plus negative 5 over 13. So this is just going to be 1 minus 5 over 13. Common denominator. So in the end, we get 13 minus 5. 13 minus 5 is 8. Right, so on the top, we get 8 over 13. And multiply 2 on top, multiply 13 and 13 on the top and bottom. So we will get, so this one times 13, and this piece times 13, right? It's pretty repetitive, but we deal with numbers and we want to get better with our numbers, right? So this is 8 and this is 26. And wait a second, 8 can reduce the 2, right? So let's not multiply. Let's just reduce it. So 2 go into 8, we get 4. You see, things is looking easier. They're getting easier as we move forward. So the next step, we have 2 over square root of 13. And you rationalize it, we get, in the end, we get 2 over 13 and root 13. Okay, last but not least, we have sine half of x, cosine half of x, right? We put a cosine half of x here, and the sine half of x is over here. And the final answer, so 13 over root 13 over 13, these are reduced. So in the end, we get 3/2. Not too bad. It's pretty nice and clean, isn't it? It's pretty nice and clean. So this is the case that terminal terminates in the second quadrant. Okay, so let's look at another example, which terminal terminates in the third quadrant for sine. Okay, so sine x equals to -3/5, and x is in the quadrant 3. Okay, let's see what happens now. Okay, so let's go back there. So this time, sine, the question, okay, given, this time is negative and the terminal is in the third quadrant. Okay, we still want to find these, you know, our goal is still the same, to find all of these. Right now it has become pretty much routine, right? And we know that we need to find cosine x from the given information. So at this point, I think I want to borrow the picture we did earlier, right? I could, why not, right? I could. There, this picture, right? This picture, I'm gonna borrow that picture. Except this time the terminal is in the third quadrant. So I'm gonna shift everything to the third quadrant, right? And that can be done. You see the commonly used non-special value are usually 3, 4, 5, 12, 13, 5. And these are the typical cases. These are the typical cases, right? So, and if you get to, if you understood these, and then it's fairly straightforward. From sine x equals to -3/5, right? We know the y is like, we know the y. So from here, it's like we know the y is -3 and the r is 5, right? R is 5. So that's y over r. Y over r. Definition, right? In the third quadrant, we were told it's in the third quadrant. So the blue is -3. And this is 5. So we now know the red is going to be -4, right? So in this case, it's pretty straightforward, right? So you can still do the Pythagorean theorem. You can still do the Pythagorean theorem. For example, I'm going to call the red, I'm going to do the marking, right? Just like, because I do want you guys to practice solving that equations correctly. Okay. So here I have this is a -3, right? This is a -3. The blue is -3. So I'm going to mark it as so -0.5. And here's a -1. No, -2.5. Oh. -1. Wait, -1.5. Okay. Don't worry about how I'm using this software. Draw your own picture and mark those points. So this piece, you see the blue is -3. That's what I'm marking. And the R is 5. Right, the R is 5. So I'm going to just mark it. Right, the R, whatever color is fine. Right, so that's the R. That's 5, right? This is marking the hypotenuse is 5. It seemed to be a little bit off, so I'm going to just move a little bit. 5. And the red, to find the red, we assume the red is X. We assume the red is X. This is pretty much the same drill. It's pretty much the same drill. But here I'm going to mark it with the red symbol. Right, so when you draw a picture, you kind of mark it nicely, clearly. Okay, so we have -3 squared, this is Pythagorean theorem, plus x squared equals to 5 squared. Okay, and then x squared is equals to 16, right? 5 squared minus 9. And then we take square root. The key steps is showing that the absolute value of x squared is x. So this is root 16. Root 16 is 4. The next step, you must show the absolute value of x. That's equals to 4. And also, you want to point out, right? Angle terminates, right? The terminal is in quadrant 3. Therefore, x is negative. Because x is negative, the absolute value of x, right? The absolute value of x is equals to its opposite, right? The absolute value of a negative number is its opposite. So as a result, x equals to -4. If you have any question about these very important details, okay, please feel free to ask me. Okay, come to my office. Okay, come to my office hours. Okay, without further ado, now we can tell what is a cosine, right? Actually, in quadrant 3, both sine and cosine are negative. So cosine is -4 over 5. We'll put this negative sign right in front of it. So now we have sine equals -3/5, cosine equals -4/5. We just plug in. Right? We just plug in. So let's do it one by one. And then we're going to discuss what happens at a half angle. Okay, what happened at half angle. So 2 times, this is a -3/5. Right? Be patient. 4/5 equals to, so that's going to be positive number, right? Because negative times negative is positive. Negative is positive. So this is going to be 24. Half x, double angle. So here you have 1 minus 2 times parentheses -3/5 squared, right? And then we have that equals to 1 minus -3 squared is 9. 9 times 2 is 18. 18 over 25. And in the end, we get +7 over 25. Okay. Tangent, we have cosine 2x, right? And we put it in the place. And the next one, sine 2x, that's 24 over 25. These number looks pretty familiar, right? In the end, we get equals to 24 over 7. Tangent, double angle found. Half angle, right? We need to determine whether we're going to choose positive sign or negative sign. Since x is in the 3rd quadrant, right? What does it mean, x in the 3rd quadrant? That means that x is larger than pi and smaller than 3 pi over 4, 3 pi over 2, sorry. Okay, And from that, if we divide these terminals, right, divide x by 2, divide pi by 2, divide this guy by 2, so it becomes 3 pi over 4. And what does this tell us? This tells us half x is in the second quadrant. Okay, so half x is in the second quadrant. This is where we get to. This is where we get to. This is quadrant 2. If half x in the second quadrant, sine in the second quadrant is positive, but cosine is negative, right? So that's how we choose. We have to choose the sign accordingly. Okay. So this is why it's important to know where the terminal, which quadrant it is in. So here we provide you with a method to determine the quadrant of half angle, right? And so we can determine the sign for the half angles. And now we can just plug in, right? We can just plug in. So now we have, we're going to replace cosine x by -4/5. Okay, so cosine x is replaced by -4/5, right? So the rest is just calculation. So let's finish it. I think we're getting better at this, right? 1 minus 4/5, that's going to be 1 plus 4/5, right? So this is plus. And 5 over 5, so that's going to be 9 over 5, right? 9 over 5 again. Okay, so the next step we're getting to equals to the square root of 9 over 10, right? 9 over 10. Oh, we get that, we multiply 5 here. We multiply by 5 here, right? Okay, next step, we just get 3 over square root of 10. 3 over square root of 10. And rationalize it, so we get 3 over 10 multiply square root of 10. And you know, provided you know how to rationalize it, right? You just multiply root 10 over root 10, right? So that's how we get there. Cosine, okay, cosine, but be careful, this time we have a negative sign in front of it, right? And inside the radicals, we have 1/5, right? So this is gonna be 1/5. 1/5, sorry. And next we're gonna have a negative. So this is gonna be 1 over 10, right? Whoops, rationalize it. We get negative. So this is gonna be negative root 10 over 10. Okay, rationalize the same way. And last but not least, we're gonna plug in numbers, right? Cosine half angle in the bottom, sine half angle on the top. But this time our tangent is gonna be a negative. So in the end, we get -3, finished. One more case, the sine, right? The sine terminates in the 4th quadrant. Okay, I just want to cover all of these cases for you so you have a reference. Okay, if sine terminates in the 4th quadrant, right? So here we have sine x equals to -5 over 13, and x terminates in the 4th quadrant. So we're going to work on that. Okay, so the next question we're going to work with is given sine x equals to -5/13 and x terminates in quadrant 4, right? We already know the routine and we have a nice picture we can use, right? So I'm going to use this picture. Except it's not in the same quadrant, right? So I'm going to take a little shortcut here in terms of drawing the picture. Okay, so you can get started drawing yourself. So here my terminal is in the fourth quadrant. Okay, so I'm going to have to move everything to the fourth quadrant. Right? So don't worry about how I do the software. You don't need to learn this. Okay. I need to learn this. And luckily, this is not too hard for me. So we got those points. Now we just have to move the numbers over, right? We'll have to move the numbers over. So you can see from this process, right? We're just playing with these numbers, really. Right, x 12. Right, so this is going to be next one, 13. Move 13 over, right? There we go. Let's see what happens. Yep, it moved over. And we know our goal is to find, so there are a couple points. Some of the part is pretty straightforward, but some of the part is determine the sine for half angle. And drawing this picture, you will need this technique for your calculus classes, right? So what I'm going to do is that I'm going to show you the use of Pythagorean theorem. Okay, but here, be careful. Actually, I think I drew the picture wrong. Because the y is -5. I drew a 12. That's wrong. The r is correct. Okay, so I need to redo the whole thing. Okay, so forgive me. I need to correct it because y is -5, right? So this 12 is wrong, right? So I need to make correction. 13 is the right place, right? But my y is -5. My y is -5. So this is going to be -5. Okay, so this is going to be this is going to be this is about right. Yeah. So this p and it's no longer -12, it's -5. Right? So x is the right place, but I like to move x over just a little bit. Okay. And 12 now is -5. -5 should be, this is going to be, so -2 here. And the 13 should be moved up. Okay, so it's gonna be uh, 7, 2. There we go. Give it a try. That 5 and 10, they're so ugly, but I don't know how to move them away. Okay, so this piece is -5, the blue is -5, and the 10 is really marking the ticks. Okay, they're marking the ticks. The hypotenuse is 13, so let me move 13 down. I'm gonna move the 13 down. Come on. Okay, and the -5 is not as well visible. So I'm going to move that -5 over a little bit. There, better. Okay, so X is still the same thing. All right, so this time we're going to still use Pythagorean theorem. I trust you, your pictures are going to be way better than mine, because I don't know how to get rid of this ugly 5 and 10. Let me give it a try one more time. Okay, 5 is gone. Maybe I can do some more, right? So make it 10, make it 10. Oh, it comes back. Okay, this is better. Okay, so this is 10. All right, not too bad. Okay, improved. Okay, sometimes it's much easier to draw on the paper, right? But if I draw with the Zoom software, it doesn't work with this software. They don't talk to each other. But anyway, I think I made myself clear enough. If you have questions, please don't hesitate to ask me. Okay, so we have hypotenuse 13. The blue is -5. We're looking for X. Okay, so we have -5. -5 squared plus X squared equals to 13 squared. And then we got X squared equals to 169. That's 13 squared minus 25. That's 144, right? You can see these academic questions, they actually make it much easier to manipulate, right? They make it easier to manipulate. You just have to understand the basic principles behind which is ARD, right? So here the square root of 14 is 12, and the absolute value of X is coming next, and that's 12. But this time, because terminal is in the fourth quadrant, is in quadrant 4. It's in quadrant 4. Okay, so X is a positive. X is a positive. If X is a positive, the absolute value of a positive number is the same as the number. So X equals 12. So as a result, cosine of this angle is equals to 12 over 13. 12 over 13. Okay, so now we just do, what do we need to do, right? Half angle, double angle, and all of that stuff. Okay, so maybe we can, if you like, you can change your theme, right? You can change your theme. And, but I would just go by, and you guys gonna work with me, yes? You're gonna go work with me, yeah? So sine of 2x equals to 2 times sine x cosine x. And plug in the numbers, right? Sine is equals to, this is going to be a negative. It's a negative, God, 5 over 13, sorry, negative 5 over 13, right? Cosine is 12 over 13. So in the end, we get negative right? We get negative. The numerator, I don't know. Let's do the denominator. 13 times 13 is a negative number. So 120. Cosine 2x. Cosine 2x, right? You can use any formula you want, really, because we know sine and cosine. How about we use the other formula for a change, right? Cosine squared of x minus 1. Why not, right? Because we know cosine already. You don't have to, you can use the other one. So cosine x equals to 12 over 13. So we're going to square that, minus 1. Right? So we end up with the same answer, and we must. So 169, 144 times 2, 288, minus 1, and this 1 is going to turn into a fraction, which same numerator, denominator, because we want to find that we want to be able to adding, subtracting them. So in this case, 288 minus 169, so 169 in the bottom, 288 minus 169. I think I'm not thinking. Okay, so just let the calculator does the work. And sine double angle, cosine double angle are both found. So sine tangent 2x, and that's going to equals to this piece put on top, and this piece is in the bottom. So in the end, we get negative 120 over 119. You don't need to convert to a mixed number, okay? Half angle, okay? Because x, okay, in the fourth quadrant, that is, right, i.e., x is between 3 pi over 2 less than 2 pi. And you know the drill now, right? You know the drill by this time. I'm going to divide on this inequality on every side. So this one divided by 2. This one divided by 2, that's going to be pi. This piece divided by 2, that's going to be 4 pi on 4 under. And pi over 2, which quadrant is this? Quadrant 2, isn't it? Yeah, is it quadrant 2? i.e., half angle is in quadrant 2. Okay, so all that work we do in here is to determine where half angle is. Okay, so now we have sine of half angle, right, equals to that plus minus, and that square root 1 minus cosine x over 2. We have to choose which sign is it. Since pi over 2, I'm sorry, since x over 2 is in quadrant 2, therefore this is a positive. Yay. How about cosine? You guessed it. Cosine, half angle is in the, if half angle is in the second quadrant, it's going to be, right? And tangent, of course, is straightforward. Okay. I'm going to do that later. We're going to do that later. It's going to be sine half x over. So after all of these are found, it's just a matter of plugging in, right? So this piece of work is to determine the sine. So now we found it. We found it. But we anticipate this calculation is going to be, not going to be too bad. Cosine x, that's going to be, what's cosine x we found? 12 over 13. 12 over 13. Right? And simplify. And this is going to be 13 over 13. 13 over 13. So 13 over 13 minus 12 over 13. Wait. Right. And after this, I'm going to take a break. So 13 minus 12, that's 1. So the top is 13 under 1. And next, we multiply 13 on top, right? And we multiply 13 on the bottom. If you watch up to this point, you've been very patient, okay? I hope you guys are also practicing your algebra. This is a perfect opportunity to practice your algebra. So this is 1 over 26. Rationalize it coming up, right? So we have 1 over square root of 26. And how do we rationalize that? So we just multiply root 26 over root 26. There we go. We have root 26 over 26. Okay. The next one, of course, we have chosen the negative sign. Negative sign. We're going to plug in the numbers, and cosine x is 12 over 13. Okay. And once again, we have 13 over 13. We are all getting better by doing these, right? And we got 13 plus 12, that's 25. So 13 plus 12, we get 25 on the top. And on the next piece, we're going to multiply the 13, multiply 13, right? Oh, very basic math. But we need that. You need that even when you're taking calculus. Okay, so this is 25. And the bottom is 26. And next, we have the negative sign still, right? The top is 5, the bottom is square root of 26. Rationalize it, right? We have root 26 over root 26. So in the end, we have negative 5 over 26. 26. You can write it this way. Yes, you can write it this way. Okay, well, of course you can write it that way too. Doesn't matter. Same thing, same thing. Last but not least, we have negative of this number, which is for cosine half angle. Sine half angle, we're gonna take this piece. Okay, that's what we got. The final answer, right? Reducing this piece, take away that piece, so we get negative 1/5. Okay, so these are the 4 cases, right? These are the 4 cases for this kind of question where terminal terminates in quadrant 1, 2, 3, 4, and when sine is given. Sine is given. Okay. I think we should all take a break, and thank you for watching. See you next time.